Look, I wish that exam was later, but because of the SSP thing, I don't think you can watch all of these videos. So yeah, during recess, so I'm going to release them as soon as possible. But the next topic is about a lot of things actually, consumer and industrial chemistry. So the first topic is oils and fats, and like this is like the most important one I think. So first of all, oils and fats are like esters. They're both the same thing, but I mean they're not the same thing, but they're both the same type, and oils are just liquid fat. So they're all esters, and the esters are produced from the reaction between fatty acids and glycerol. So glycerol is also known as propan 1,2-tritriol. No need to know that, I guess. But yeah, fatty acids plus glycerol produce fat and 3 water molecules. Here, you have to mention the water molecules. You have to remember that one. So yeah, the difference between oils and fats are they are liquid and solid. But the reason why they're liquid and solid is because not all fats are like this. Some fats can be saturated, some fats can be unsaturated. You can see that there's an R group here, kan R1, R2, R3. These are all the same, but this R here can be different. It can be it can be a clean saturated fatty acid, or it can have double bonds. So when it has double bonds or triple bonds, they are unsaturated. So normally when you have this like saturated, if you have this like bonds, unsaturated bonds, it means that it will have a low boiling point and a low melting point. So because it has a low melting point, that's why oils are liquid at room temperature, because they have a low melting point. And the reason why they have a low melting point is because they are mostly unsaturated fatty acids. So they're not all of the acid, not all of the oil. No, you're not. Not all of the fatty acids are the same. Like it could be, some could be saturated, some could be unsaturated. But oils in particular have a lot of unsaturated fatty acids, and fats have a lot of saturated ones. So here's the examples: palm oil and butter. Okay, I already mentioned this. So how do you convert unsaturated fats to saturated fats? You know how to break carbon. How to break these double bonds? You have to add hydrogen to it. So the reaction is called hydrogenation. And yeah, remember nickel. Yeah, just remember that nickel's a catalyst. Okay. Okay, these are the uses in uses of oils and fats in life: biofuel, nutritional salts, animal feeds, and soap and personal care. I'm losing my voice right now. I can't even speak straight. I'll talk about this later. Here, yeah. These are all logic lah. Just don't eat too much fat, or you might die. Okay, cleaning agent. This is the most important subtopic. You need to know a few things. Number one is soap and detergent. Like how do they clean? Why is detergent better than soap? And how do you make soap and detergent? So soap are fatty acid salts, and the cation is the fatty acids combine with sodium or potassium. Remember this, they are sodium or potassium. And that's because these are +1, and fatty acids anions are also -1, so -1 +1 lah. So it is more efficient, more stable, I guess. So just take note of that. As you mentioned earlier, fatty acids are long chain carboxylic acids. Remember carboxylic acids? I forgot how you form them again, but basically they have COOH, and then they have a lot of these carbon and hydrogen at the back. So yeah, okay. Here, okay. R is an alkyl group containing at least 8 carbon atoms, but it's usually 12 to 20. It can either be saturated or unsaturated. So the examples are sodium laurate from coconut oil and sodium palmitate from palm oil. That's why you always hear that soap can be made from oil. It sounds weird, right? But it makes sense when you actually think about it, because the fat can be mixed with sodium or potassium to make the soap. Okay. How about detergent? So detergents are are made because because there was not enough oils to make soap. So instead of soap, you use detergent. So detergents are actually sodium salts of sulfonic acids. So number one, they instead of being sodium or potassium, it has to be sodium. Well, at least the examples here are sodium lah. And there are two main types of detergents which are using alkyl sulfonic acid and using alkyl benzene sulfonic acid. So yeah, alkyl is it can be like methyl or no methyl lah. It can be like octyl or nonyl, but alkyl here is because there's an R group here, so it can be any number of carbon atoms. So there's no exact like type. But yeah, sulfonic acid. The main difference is here is oxygen and here is benzene. So you don't have to know what benzene is. You don't have to know what that other thing is. I think it was what was it again? Styrene, I think it was. But yeah, you don't really have to know that. You just have to know that detergent is made out of either alkyl sulfonic acid or alkyl benzene sulfonic acid. So how do you prepare soap and detergent? So soap, you mix the oil and or fat with alkali. So it has to contain sodium or potassium lah. So you mix them with either NaOH or KOH, and then you will get soap and glycerol. So glycerol is your byproduct. So oil and fats are natural esters known as triglycerides. If you remember chapter UEC senior 1, you'll know what triglycerides are. So so the reaction, you have to know the name. The name is saponification. This is how it works. So how about detergent? So detergents have two separate reactions. Number one is sulfonation, and number two is neutralization. I think the book actually mentioned either sulfonation or sulfation. So here the book has a slight mistake, but basically yeah, they are the same thing actually. So sorry, my thing hurts. So it's either sulfonation or sulfation. So for sulfonation, it's for the alkyl benzene. For sulfation, it's for the alkyl. So it mentions here sodium alkyl sulfate. So my mouth hurts. Okay. So for sulfonation, you react the alkyl benzene with the sulfuric acid, and you will get water as your byproduct. And then after that, you neutralize this sulfonic acid here, and then you'll get another water, and then you also get your detergent. So the overall reaction has two water molecules. So take note of that. So the difference between alkyl benzene and sodium alkyl benzene sulfonate and sodium alkyl sulfate is sodium alkyl sulfate is you start the first reaction with alkyl benzene, while you start the second reaction with alcohol. But they are the same process. You just add sulfuric acid, and then you'll get water, and your product you neutralize that product, and then you'll get water again. Of course you have to react it with sodium hydroxide lah, because neutralization you must have acid and alkali, so they react them together, and then it will neutralize lah. So that's that. Okay, this is my favorite part. How do these things actually work? How do they clean? So I'll just explain it with my own words. Since these two are salts, you can ionize them. So when you ionize them, you get the ions, the cations and also the anion. So we call them soap anion or detergent anion. So remember how the anions come from the fatty acid. So remember that there's like a huge carbon chain here. So remember that in the chapters we learned before, for things to be soluble in water, you need to have something that can form hydrogen bonds. But there are no atoms that can form hydrogen bonds with the water. So these are insoluble. So because they're insoluble, they don't like water. So we call them hydrophobic. But the front part here does have oxygen. So we call it hydrophilic because it likes water. So we have a hydrophilic head and a hydrophobic tail. So with that in mind, hydrophilic head is soluble in water, and hydrophobic tail is soluble in oil or grease. Not in water, but in oil and grease. So take that in mind. Okay, so okay, first of all, when you add, you can reduce surface tension. I think this is something that should be known. But it's not important. The important part is here, this part. So how does it remove the grease? First of all, it ionizes, and then when it ionizes, because the cations like not the cations, the anions like grease because there's a hydrophilic head, right? A hydrophobic tail, it will go into the grease because it likes grease, and then the head doesn't like grease, so it sticks out in the water. So now you have these like tadpole looking stuff, looking very sus. You have these things all on the grease, and then slowly they will accumulate. They will slowly like get more and more and more together. So it will slowly accumulate to become like this. And after that, when you scrub the water, when you scrub your clothes, it will cause the grease to get out. But you know how like bigger grease stains are harder to clean, right? It's easier to clean those small grease stains, but it's harder to clean those big ones. So what it does here is, remember how they are anions, so they have negative charge. So what happens is, they don't really like each other. So when you scrub that grease off, and when these things help because these anions help to lift up the thing, but also when you scrub it and then it leaves the cloth, they will open up a space here. Then the anions will go here as well, so it will make it more negatively charged. And then you have all of these negative ions to get fighting for the grease. So because of that, they'll keep repelling, and then when they keep repelling, eventually the grease will break into smaller pieces. And then after they break into smaller pieces, then they will continue repelling amongst those smaller pieces. So you see that there's a lot of anions here, and then the anions hate each other. So because they hate each other, they will try and break out of each other. So it will become smaller and smaller and smaller, and then they still don't like each other. So they'll keep repelling each other so that the grease does not go back on the cloth, because there's always going to be a charge trying to push them away. So yeah, that's why the grease does not stick back onto the cloth, because the negative charges of every grease stain will repel each other, so they'll keep pushing around, so they won't go back onto the cloth. And then after that, you can just rinse it. You can just put more water on it, and then the grease will wash away. So why is detergent better than soap? The reason why is because scum. So what happens? In hot water, hot water is water that contains impurities, and that impurities also include calcium ions and magnesium ions. So these are called hot water because they are harder in texture. So why is it not good for soap to clean hot water? That's because when you instead of the when you know how the ions will ionize to become cation and you know how the soap will ionize to become cation and anion. The anion will go to the grease can, but then some of it will instead react with the calcium inside or the magnesium inside. So because of that, wait for it to load. So because of that, it will combine. They will combine to form scum, and scum is a white precipitate. It is insoluble in water. So when you have a lot of these insoluble stuff in the water, when you have this scum in the water, it gets harder to clean the cloth, right? Because there's a lot of things blocking the grease from getting clean. The scum is blocking the grease from getting clean. So because of that, it makes it less efficient. It makes it slower. So in the end, you waste soap. But detergent can, when they react with the ions, they don't form insoluble salts. They form soluble salts. So it doesn't affect the process. So that's why that it is not good in hot water. For acidic water, it's the same situation. it will form insoluble substances so that it will make the process slower. By the way, you can add detergents. You can add additives. Read this yourself. But the most important one is biological enzyme and their types: amylase, protease, cellulose, and lipase. So that's because they are very good at cleaning protein stains. So these are for grease stains kan. But if you add some special things to your if you add these enzymes, they can also clean protein. I don't think there's anything else to mention here. Yeah, read yourself. Okay, food additives. So they make you add these additives to food to make them last longer, to make them taste better, to make them appear better, to make them have a better texture. So what are the types? There's the preservatives, which will cause the food to last longer because it delays the growth of bacteria. So the most common example is salt, sugar, and vinegar. But they also mention a lot of benzoic acid. So I think they'll mention like, this is very important. I think this is the most important additive. If they ask you for an answer, you should answer benzoic acid to be safe. If they ask you to like suggest a type of additive. But if they talk about fish, you add salt. If they talk about jams, you add sugar, and so on. Next is antioxidants. So antioxidants make the oxidation process slower. So normally these things are acids, and they prevent the food from becoming rancid. So basically what rancid means is it becomes very icky, or it just tastes bad, and that's because of oxidation. Food becoming rancid is actually oxidation. So the examples are vitamin C or ascorbic acid, citric acid, and tocopherol. So if I were you, I will memorize these two. For flavoring, it makes the thing taste better, or it replaces the original flavor. So the examples are MSG, aspartame, sorbitol, and stevia, and then also propyl ethanoate, ethyl ethanoate, and some other esters. If I were you, I will memorize esters and aspartame and sorbitol. Those two are the most commonly mentioned. And then the stabilizers to give it a better texture, a smoother texture. For this one, pectin and agar. So pectin for jellies, pectin for jam, agar for jellies. And then there's also emulsifiers. So it's just to make two liquids mix together. Not really mix, but it makes them it just makes them form an emulsion, so it's easier, or it's better. So the main example is lecithin in chocolates. So like for example, Milo, there is lecithin in your Milo, and then it's also these monoglycerides or triglycerides. So this is basically your fat lah. No fat. This is your fat. So technically, you add other fats, if I'm not wrong, into your thing. But that's not the main point. The main point here is the lecithin. You have to know what lecithin is and what it does. So if you talk about anything that is about chocolate, like Milo or Vico or Kit Kat, they all contain lecithin. And then there's also thickeners. So they thicken liquids. They make the liquids more thick, have a stickier texture, I guess. So the main ones you have to memorize are starch and gelatin. And lastly, dyes. So dyes just make the food look better, look more attractive. So yeah. These are the reasons why you want to use them and why you shouldn't really use them too much. Read them yourself. Okay, next is medicines and cosmetics. So we all know what medicines are. They are chemicals to help with to treat diseases, and usually they're safe, but do not overuse them because if you abuse them, they can be harmful. So there are two types: traditional and modern medicines. So What are the examples of traditional medicines? Ginger, aloe vera, tamarind, and ginseng. So the thing themselves are not the medicines. They contain certain chemicals, or not chemicals, they contain certain substances, that can be used to treat the body. So for ginger, it removes wind from the body, so it's like for stomachache, prevents colds, and it makes your body warmer. Aloe vera is to treat skin stuff like diseases or wounds. My father uses this a lot. He even asked me to apply it on him because his skin was burning. So yeah. And then there's ginseng. For ginseng, it is for immunity, and tamarind is for coughing and skin brightening. All these races. Next is modern medicines. So I'm sorry for that one, by the way. Okay, modern medicines. There are 5 types of modern medicines. I mean, there are 5 types mentioned here. There are actually a lot of types. Number 1 is analgesics. So analgesics are for relieving pain. So they make you ease the pain. So there are many types of analgesics. There is aspirin, paracetamol, and codeine. So for codeine, it is for coughing and diarrhea. But for aspirin and paracetamol, those are for fevers, or Panadol. Panadol is actually paracetamol. So like, they are more for current pain. Like maybe you feel like pain, like maybe you feel headache. Maybe you feel feverish. So they relieve those stuff. So those are called analgesics. So remember, most people don't know what these are, but they don't know what their type is. So the type is called analgesics, and these ones are, yeah, you just rinse yourself lah. Just don't overuse them. Next is antimicrobials. This is another one that people like to forget about its general type. The whole thing is called antimicrobial. But there are many types of antimicrobials. For example, antibiotics, antiseptics, and disinfectants. For disinfectants, they are to kill pathogens. So you don't want to be eating them. You want them to make your room free from these pathogens. Instead of killing, if you eat them, you might kill yourself instead. So yeah, be careful of that. So antibiotics are the ones that will kill bacterial growth in your body. Antiseptics are for your skin, and disinfectants are for your room. So yeah, take note of that. And know the examples as well. Especially know the examples as well, especially penicillin. So yeah, the main thing about there is one very important thing about antibiotics. You need to fully consume them. If you know how when you go to the doctor and then they give you antibiotic, they must say you must finish this, or else you might die. Not really that you might die, but you must finish it. Why? Because they give you an amount that is enough to kill all of the bacteria in your body. They want all of the bacteria to die, all of them to die. They want all of them to die, because if they don't die, they will adapt. The bacteria will adapt, and then they will mutate, and then they'll be immune to it. So you don't want that to happen. So you want to kill everything before you want to kill all of the pathogens before they duplicate, before they mutate. Next is psychotic drugs. For this one, I don't really want to look at the book much because teacher actually added a few things, like antidepressants, and I forgot what's the other one. For these 3, they are a treatment for psychosis, which is a mental illness, which causes hallucination. So the other ones are antidepressants, and I forgot what's the last type. I'm gonna go and get my book first. You can go drink water or something. Okay, I'm back. I got my teacher's notes. So she added a few stuff. First of all, there's also stimulants, and the examples of stimulants are like amphetamine, meth, and caffeine. So because they're also drugs lah. That's why she included them. And then there's also antidepressants like tranquilizer. I think this one I'll spell tranquilizer. and then there's barbiturate. Barbiturate. So these are also drugs, but they are antidepressants. And then there's also antipsychotic drugs, and the example for this is lithium carbonate. So these are all to treat illnesses lah, but don't overuse them because overdose. Okay, next is anti-allergies. So they are for like runny nose and itchiness, because allergies, right? The examples are antihistamines. And lastly is corticosteroids. So corticosteroids are for wounded areas to reduce the swelling, or to reduce any wounds, any rashes. So yeah, the example, I'm not going to read that. This basically says it's good, but don't overuse it, don't overdose. Yeah. Next is cosmetics. So cosmetics are materials or products that are used to cleanse, protect, or enhance someone's appearances. So there are many types of cosmetics. There's dyes. So the dyes are to give color. So they contain iron. Why would you put iron into your thing? Never mind. Next is water. What? I didn't really pay attention to this part. Next is emulsifiers. Again, the same thing is here again. Next is thickeners, glycerin, fragrances. This is for smell. Moisturizers for the moisture stuff. Like I'll go as an example. Lipstick. And then there's preservatives, so they don't spoil. Okay, next is no, not next lah. There are three main types of cosmetics: makeup, treatment, and fragrances. For fragrances, it's to smell good. For treatment, it's to make your body not swell, make your body not have too many pimples. For makeup, it's to make your face prettier lah. I'm not a makeup guy, so these are the benefits and harms. I don't really need to mention this much. I do wonder why they use mercury for makeup. That's kind of sus. But yeah. Next is nanotechnology. So nano means very small, like very, very, very small. So nanoscience is studying very small things, and nanotech is developing stuff using very small things. So I think the main example that they want to talk about here is graphene sheet. So I'll just mention graphene. Let me see the applications. I don't know if they'll mention more about these examples. Semiconductor, energy, textile, medical, agriculture, drug delivery system. Ooh. And food. Yeah, I think you can read this yourself. And then next is development in the field of nanotechnology. So my teacher particularly liked to mention graphene. So graphene is actually carbon. It's a carbon allotrope. The other allotropes include I think it was graphite and diamonds. Yeah, they're all carbon, and they're all in a special arrangement. So for graphene, it is a hexagon. Oh, my bad. But yeah, graphene is quite special because graphite is combining multiple graphenes together. But graphene is just one layer. We call it a graphene sheet. So one layer only. And it is it's actually quite hard. So yeah, it is very good. I'm gonna see if I added anything else about graphene. It just mentioned here that graphene can be converted into other stuff like graphite, carbon nanotubes, and fullerene balls. No, I didn't add anything, but it did mention its properties. Graphene is actually very good at conducting. I don't know why. Oh wait, no, I think I do know why. So you see how graphene sheets have 1, 2, 3 connections of carbon. 1, 2, 3. Remember how carbon has 4 slots? It has 1 remaining slot, one hole. So that's why it can conduct electricity. Next, it is transparent. Third, it is elastic. Fourth, it is impermeable. So it cannot be penetrated. So like it's very resistant. So like if you were to shoot a graphene a graphene vest, it's actually bulletproof. So and then it's elastic, strong and hard. very low resistance, but it's quite expensive. So yeah. Okay, these are the users. Oh, I'm losing voice, so I'm just gonna let you guys read this for a bit. Okay, yeah, I mentioned this one here. The arrangement of atoms. As I said, it has three bonds. So it has one remaining bond for the electron. So because of that, it can form a lot of it can become a conductor. Okay, lastly is green tech. So green technology is a technology or application developed to minimize the negative effects of harmful human activities. I'm not so sure what's anything that is really important here. I don't think it's in this page. There's like a page where teacher mentioned a lot. Okay, these are quite obvious lah. Like how do you apply green technology? How do you become a good guy? How do you not be a bad guy and pollute everything? So this is like what are electric cars, is environmentally friendly buildings, industry, use less energy, use compost instead of like those fertilizers, recycle, and use renewable energy. Okay, green technology. Okay, this is the thing that teacher like to actually mention quite a bit. So, how do you apply green technology in your wastewater management? Okay, carbon footprint again. Oh, I have to go talk about carbon footprint. Okay, waste management. Oh, okay, I haven't read this part yet. Oh god. Okay, here, wastewater management. So wastewater is like very polluted water, has a lot of waste. Human waste, food waste, oil and chemicals. So there's either domestic wastewater, stormwater runoff, and industrial wastewater. So domestic wastewater is like your toilet bowl. There's stormwater runoff, which is like water like storming down into your longkang, I think. And it's also like from the factories. And they contain a lot of very, very dangerous stuff. So yeah, be careful. We don't want them in our environment. That's why we need to filter this wastewater. We need to manage them properly. So how is the current green technology for wastewater management? So first of all, they use something called electrocoagulation. So after you pump in the wastewater, I think it's called sedimentation. I forgot what it's really called. But you remove the solid waste, and then after you remove the solid waste, I think it's called filtering, and then you remove the waste, you bring it into the electrocoagulation tube or chamber, and it is electro, so it contains electrodes. So it has carbon electrodes or copper electrodes. So yeah, there's electrodes, and then you can use wastewater, and then the wastewater becomes electrolyte. So you know how some pollutants are like salts or yeah, just they're salts, or they can be ionized. Oh no, they don't have to be ionized. They can be ionized by the process itself. So yeah, inside the wastewater, inside the place undergoes electrolysis, and then they will stick onto the electrodes. So when they stick onto the electrodes, they will form these sludge. So yeah, because these impurities go to the electrodes, they will like accumulate there. So the water that you get is cleaner. After that, you take the sludge away, and you can make natural fertilizers, and then or you can just get rid of them in a better way lah. And then the water that you can use, the water that you got from that electrocoagulation process, you can actually treat it more after you treat it more. So you electrocoagulate it, and then you bring it here, you separate the sludge and the water, and then the water goes down, you treat it a bit more, so like you add those extra processes, I forgot what they are, and then and then after that you get the cleaner water, which is good for planting. And then there's also the importance. I'm pretty sure these importance are very logical. They make a lot of sense. So I'm not gonna read this. I might read this like in my head, but I'm not gonna mention it. I'm not gonna explain it more because these are very logical, like better waste management, get rid of global warming. Yeah.